Okay, I've got a device here. I've got two streams of water. They're all at 3 bar. One comes at 200, one comes in at 100, and the mass flow rate of this higher one is twice that of the lower one. And then I've got one exit that exits with a mass flow rate of 54 kilograms per hour. There's no heat loss in the engine, no kinetic potential energy effects. Okay, so I want to find the maximum power that can be developed in this sort of thing. Okay, so what I need to do is I need to start with my first law equation, okay, which is going to be Q dot minus W dot equals the out minus in, right? So that'll be M3H3 minus M1H1 minus M2H2, right? Q goes to 0. This is my first law equation, right? Q goes to 0. I neglected potential and kinetic energy effects as well, okay? So I can find my work once I find essentially my mass flows and my H values, right? So the first thing I'll do is I'll figure out my mass flow, right? Which is basically going to say that mass flow in equals mass flow out, which is M1 plus M2 equals M3, okay? Which M1 actually equals 2 times M2, so it'll be 2 M2 plus M2 equals, and then I know that mass 3 equals 5,400 kilograms per hour. So from this I can calculate that mass 2 converting to seconds is actually 0.5 kilograms per second, and mass flow 1 is 1 kilogram per second. Okay, and this guy is then going to be 1.5 kilograms per second. Basically, just dividing that by 360 seconds gives me that. Okay, so now I know my mass flows. Now I just need to find my H values to figure all of this out. Okay, so initially I know 200 and 100, so I come over here, I go to 3 bar, and at 200 degrees my H value is 2865.5. I'm going to get my S value. I'm going to tell you why in a little bit. That's 7.3115. I'm going to write all of these down. We're going to use them both here because I'm going to need those in order to find my H values. Okay. Now you'll notice saturation is 133, so I'm actually at 100. So I'm a liquid, so I'll approximate that as a saturated liquid at 100 right here. My H value here is 419.04, and my S value is 1.3069. So let me go ahead and jot all of these guys down that I found. So again, H1 equals 2865.5. S1 is 7.3115. H2 equals 419.04, and S2 equals 1.3069. Now, again, I haven't found H3 yet, okay? So I need to figure that out here, okay? And I'm going to do that using my second law equation, okay? And my second law equation for steady state is given by this, which is Q over T plus that'll be mass flow in, which is going to be M1 S1 plus M2 S2 minus the mass flow times S3 out plus CV dot, okay, or sigma dot. Now, there's no heat transfer, that goes away. I'm trying to find the maximum, meaning best case scenario, meaning completely reversible. So sigma is also going to go to 0. So now I have all of my mass flows, and I have S1 and S2. From this, I can calculate S3, which is going to be 5.31. Okay. Now I know, again, from the problem statement that I've got P3, equals 3 bar. So now I can use these two values to find H3. So I go to 3 bar again. Okay, we'll start in the pressure table. So at 3 bar, you can see that your maximum entropy for saturated vapor is just about 7. Saturated liquid is 1.67. Again, I'm at 5.31, so I'm in between there. Okay, which means I'm in between here, between 640 and 2700. When I do the interpolation, I find that I get 2041.2. Okay, and again, I know this because I found S3, I know P3, interpolating in the saturated liquid table between, what was it, between 1.6 and 6.9 for my S's. I then interpolate between my H values to get that H value. Now that I have that, I can go back up here and use, now that I have H3, H1, H2, all my mass flows, I can calculate the maximum work put out by this guy, and I actually find it's 13.2 kilowatts. So in this problem, we used kind of all three of our equations. We've got conservation of mass to figure out my mass flows. Okay, I use the second law equation, knowing that I want it to be reversible, so sigma goes to 0. I use that to calculate state 3, because again, I know state 1 and state 2. Once I have S3, I use it with the pressure to then look up the value for H3. Then when I have that, I go to my first law and calculate the maximum work of the turbine.